Hello, good evening, everyone. Please confirm once that you can see me, you can hear me, as well as you can see the slides. Okay, thank you so much. Let us start the session. Very good evening, everyone. My name is Ambuj. I am research scholar at Agriculture and Food Engineering Department from IIT Kharagpur. I will be taking your live interactive session for this particular course, that is Data Analytics with Python. This course is taught by Professor A. Ramesh from IIT Roorkee. Okay, so what we'll be doing in this particular session, we'll be solving some of the objective type of questions based on the previous week's content in front of you all. Okay. First, to try to provide your opinion, then I'll explain you the concepts in detail. There is no separate Colab notebook for today, just for today, because the codes already I have written in this particular PDF only. Okay. I'll show you that. Meanwhile, you can copy them, okay, and try to use them in your Colab notebook. Okay. So let us begin. Question number one is this: which library is used for calculating distance measures in clustering using Python? Whether it is distance underscore matrix, whether scipy.spatial, scipy underscore spatial, distance dot matrix. Do try to give your opinions, then we will discuss. B. Okay, good. The rest of the students also, they should try to communicate their opinions. Yeah, B. Good. Good. B. B. Okay. Good. Yes, B. Library used for calculating distance matrix in clustering using Python is scipy.spatial. It provides functions like pds and cds to compute distances between data points. Yeah, but correct. There is no problem. Join in. See, try to look at option A. It is distance underscore matrix. It won't be correct. Okay. Distance underscore matrix won't be correct. This is how you can declare a function in Python. SciPy underscore special, this won't be correct because the question is asking which library. That is the question. Okay. So either it would be SciPy dot spatial or distance dot matrix. Okay. But the correct option would be SciPy dot spatial. So to eliminate two options directly, you can eliminate. Okay. That is the thing. Question is asking which library is used for calculating distance measures and clustering using Python. Correct answer is scipy.spatial. Okay. Now you try to see why. Because in clustering, you often need to compute that how similar or to this or dissimilar two observations are. You try to make the clusters. Okay. Most common way is using the distance metric. Either it can be Euclidean, it can be Manhattan, it can be cosine. Many of these are available under scipy.spatial.distance. Okay, that was the library that was being mentioned. Scipy.spatial. Okay, when the option says scipy.spatial, that module is specifically deciding your distance tools. Okay. This is how you can just calculate it. Okay, you just have to provide the coordinates in the braces. Why distance is important in clustering? Because clustering algorithms are based on closeness. Or for example, if two students have similar marks in subjects, they belong to the same cluster. If two customers buy similar products, they will belong to the same customer segment. Two pixels in an image, okay, if they are having same color values, they can be grouped together. So clustering often asks how far apart these 2 points are. Okay. And far apartness is the measurement of distance measured. Okay. So if you are given two different points, suppose A is x1 comma y1, B is x2 comma y2, then Euclidean distance would be the straight line distance, that is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Short example also is given here, you can try. If you come to Manhattan distance, that is nothing but the sum of absolute differences. For the same points, it would be the modulus of x2 minus x1 plus modulus of y2 minus y1. Modulus you generally have to take, okay, so that you can eliminate the negative numbers, okay, negative distance. Okay, it is useful when movement is just like a grid or the city blocks. Okay. Then you come to Minkowski distance. Okay, Minkowski distance. Okay, so this is a generalized form of Euclidean or the Manhattan distance. That is nothing but summation xi minus yi raised to power p whole raised to power 1 by p. If p is equal to 1, okay, if p is equal to 1, that will converge to what? Your Manhattan distance. And if p is equal to 2, then it will converge to Euclidean distance. That is the thing. Yeah, don't get confused. It would be written in same format manner. Okay. It would be written like this only. X2 minus x1 mod p power p plus y2 minus y1 whole mod raised to power p. That in itself raised to power 1 upon. As a summation, you need to do it for all the points. That is your Minkowski distance. Then comes your cosine distance. Okay, cosine distance is nothing but your it is used to it is used when direction matters more than magnitude, especially in text data and high dimensional data. It is based on the cosine of the angle between two vectors. Cosine similarity is given by cos theta equal to magnitude of vector A multiplied by magnitude of vector B in denominator and the dot product of both the vectors in numerator. Okay. This is your cos theta. So cosine distance is nothing but 1 minus cosine similarity that is given by this particular expression. So cosine distance will be equal to distance equal to 1 minus cos theta. Okay. It is used in text clustering, NLP, natural language processing, okay, and your recommendation systems, as well as in various systems it is used. Okay. Text clustering is related to your NLP only. Okay. And then recommendation systems. Okay. If the total number of values, for example, nowadays weather updates are coming. Okay. Weather updates are coming on an hourly basis. So what they have done, they have taken 16 or 17 weather parameters. Okay. 16 or 17 live weather parameters they are taking using satellites as well as various ground-based stations. Okay. So what they are trying to do, they have observed the atmosphere for over 200 years. Okay. They have analyzed the data for over 200 years. Okay. And now they have clustered, they have formed various clusters, okay, in those regions. If the parameters will fall, okay, in those particular clusters, they'll be declaring that you might experience a thunderstorm or a bad weather event, okay, or a harsh weather condition. Heat stroke, okay, heat stroke might be there, or a thunderstorm would be there. Okay, both the possibilities are there. So how they are able to predict that? Because the values, okay, of the parameters like atmospheric pressure, temperature, humidity, relative humidity, then dew point temperature, saturation temperature, all these parameters are there. Okay. If the values lie in particular format manner, then they will predict on the basis of the data which they have analyzed for over 200 years. Okay. On that particular basis, they will be saying that, sir, you might experience a particular dangerous weather event. Okay. It may be a heat stroke, it might be a thunderstorm, it might be hail, snowfall, anything in upcoming 10 hours, 12 hours, 2 hours, 3 hours, whatever is the time limit. So that is how they are sending the messages. Okay. So this is an example of your recommendation system. Similarly, recommendation systems are there in case of your nuclear power plants. These are very sensitive recommendation systems. Okay. Now, on the basis of those recommendation systems, as well as on the basis of various sensors, the quantity of the fuel which has to be injected, okay, into the reactor is decided. And when these systems fail, then a lot of crisis happens. That is the so that you try to keep it in mind that these are very very important for you to understand. Okay, most of you would be working in some of the companies, okay, or some of the corporate uh, database analytics companies. Okay, so in those particular companies, okay, which generally have the access of highly classified information. Okay, the companies, they are bridge companies. Okay, so directly from a sensitive area like a nuclear power plant, okay, that data will be transferred or given to a company, data analytics company. Okay, there are a lot of options. I'm not taking one particular name, and that company will be assigning the data to you. Okay, you as a candidate, okay, or as an employee. Then in that particular form and manner, you have to maintain utmost secrecy. Okay. You cannot share this particular data with any of the people. Okay. Maybe your friends. Okay. You have to maintain the utmost secrecy. That is our work ethics. Okay. When it comes to data analytics, don't share the client's data with anybody. And always keep your laptop at your desk and leave it then and there only. Okay. Don't bring your work laptop or your desktop or your computer to your home. Okay. That is how you can prevent any of the data leaks. Okay. So in that particular format manner, you have to be you have to maintain utmost secrecy. Okay. You have to analyze the data, share the results only with the client or your supervisor or your boss. Okay. That particular information has to be just communicated to you because if you would be doing some internships in data analytics companies, yeah, then they will initially brief you for over 1 month on this topic only. Okay. But if you are directly employed, then you won't be having a chance. That is why I'm telling you here itself. Now you try to see another one is your Hamming distance. Hamming distance counts the number of positions where values differs. Used for binary data, categorical data, or encoded strings. Okay, binary data is will be in the form of 0 and 1s. Categorical data already told you it would be in the form of categories. Category A, category B, category C, and number of values. Okay. Encoded strings. Encoded strings means coding and decoding. You must have solved these type of questions for your competitive examinations. Okay. Suppose there is a particular code regime in which A, B, C, D is written as Z, then Y, then X, then W. So that particular is an example of encoded string where there is some pattern. Okay. The string in itself is encoded. Okay. Encoding means the string is not stored directly. Okay. Suppose hello world is there, that is not stored directly. It undergoes some coding regime and then afterwards it is stored in the cells or memory cells. Okay. So this is an example of encoded strings. So Hamming distance just counts the number of positions where values are defined. Where are the distance available in Python from scipy.special import distance? This is where the distances are available in Python. You can import Euclidean, density block, cosine, p distance, c distance, all the types of distances in the module which is scipy.special. Then distance underscore matrix, I already told you it is not a main library or a module. Underscore distance underscore matrix is how we can declare a function. Okay, so it won't be correct. Then scipy dot special, it is the correct option. Already told you. Scipy underscore special, no, it's not a valid Python module. It can be a function name. Then distance dot matrix, this is also not a standard Python module. Okay. So with the wrong format as well as wrong module name, it won't be correct. Now, if I tell you what is a distance matrix is just a table which is showing the distance between every pair of points. Okay. P1 is suppose 1 comma 2, P2 is suppose 3 comma 4, P3 is suppose 3, 6 comma 8. Okay. Distance matrix will be nothing. All the diagonal elements will be equal to 0 and pairwise distance. Okay, will be just written here. Okay. Distance P1, P2, P1, P3, P2, P1, P2, P3, P3, P1, P3, P2. Okay. Just you can remember like this. P1, P2 is written here. Then P2, P1 is written here. Then P1, P3 is written here. P3, P1 is written here. And P2, P3 and P3, P2. Likewise, you can just try to write it down, and in one or two goes, you will be able to remember this distance matrix. Okay. Heavily used in clustering algorithms like hierarchical clustering, agglomerative clustering, DB scan, K meteoroids. These all are the latest clustering algorithms. Okay. From here onwards, whatever you will be learning, okay, that would be very, very much applicable to your practical projects. Okay. So on clustering itself, you can make several projects, okay, in which you can analyze any of the open source available database. And you try to share your GitHub repo, or you can mention your GitHub repo in your CV. That is the thing. These all are related to the practical aspects. What are the practical aspects of this particular course? Okay. And how you are in a position you are able to deal with the practical data. For example, a lot of data you would be analyzing if you would be working for some of the, I already told you, data analytics company. Okay. So in that particular format manner, number of rows, number of columns will not be limited. Okay. Now, in this particular course, whatever examples we are analyzing, they are very limited. But they are very limited because you are just learning. Okay, you are a learner. But when you will take it as a job, then you have to analyze millions of rows, okay, at a time. And there you will be using some HPC, high competition clustering algorithm. Okay. Some algorithms would be different, and as well as the devices on which you would be running those particular algorithms, they would be having parallel computing. Okay. So just keep it in mind. So just from coding perspective, if you have to calculate the Euclidean distance between 2 points, you have to write from scipy dot spatial dot distance. Import Euclidean. Okay. A you declare any of the as an array, any array, okay, with having which is having the coordinates of the points. Suppose A 2, 3. Then B is 5, 7. And dist is the Euclidean. Euclidean is the function, and in this particular function, I will be passing my both the coordinates as a parameter, A, B. And then print Euclidean distance. Okay. And then you write colon, and then afterwards you write dist. So Euclidean distance is 5 is coming in this particular case. When calculated manually, 4 square plus 3 square, that is 5 only. Okay. That's correct. The Manhattan distance, similar to your Euclidean distance, just you have to write from scipy dot spatial dot distance, import city block. Okay. This is your Manhattan distance. Okay. This step you have to remember that Manhattan distance is not written as Manhattan distance in the Python library, which is scipy dot spatial dot distance. It is written as city block. Then as a parameter passing to the same points, what you will get? You are getting Manhattan distance as 7. Okay. I think 5 minus 2 is 3, 7 minus 3 is 4, 4 plus 3 is 7. Okay, so it is correct. Then cosine distance from scipy dot spatial dot distance, import cosine. Okay, you have to import the cosine value. Okay, then cosine distance is declared as a cosine function only. Then it is written here vector A dot means A vector. Okay, it should have I, J, K. Okay, so three values I have provided. Then vector B, I have given I, J, K. All the values I have given here. Okay. Then dist equal to cosine of A and B. A and B as a values I have given as the parameter. When you try to calculate the cosine distance will come at 0 because both the vectors are pointing in the same direction. Okay. 1, 2, 3. Okay. You can take common 2 here, then it will be reduced to the same values 1, 2, and 3. So two vectors, okay, if they are pointing in the same direction, then what is the angle between them? Angle between them is 0. That is why cosine distance is coming is 0. Okay. That is the thing here. If two vectors are pointing in the same direction, then a cosine distance will be equal to 0. Then pairwise distance using PDIST. Okay. Very important in clustering. Okay. Scipy dot special import PDIST, import numpy as NP, then NP dot array. You try to declare all the values. Okay. Then distance. P distance you try to calculate as a parameter. You just pass on this array. Okay. Then metric you can keep it Euclidean. So 10 distances. So distance you are getting over. Pairwise distance you can also you are also able to calculate. So these are the values which are coming. These are the distances between point 1, point 2, point 1, point 3, point 2, point 3. P distance will give you the pairwise values. Extremely useful in clustering. So if I give you if I increase the number of rows to 1000, just remember you have to declare the entire CSV file. Okay. You will be provided a CSV file and you will be asked to analyze that particular data set. Okay. Not talking about in the examination, I'm talking about the real aspects, okay, of this particular course. So if you are given a CSV file and you are asked to just uh, provide the explanation or of the data, how that particular data is variation is there. Okay. So the entire CSV file, okay, it will be having high number of rows, high number of columns also. Okay. So one very simple trick is there that you can make arrays. Okay, you can make arrays in form of columns and keep all the indexes same. Suppose there are five number of rows and three number of columns. Suppose data is like this. Okay. This is column number one, column number two, column number three. Values are will be like this. Something here all itself. Okay. Suppose there is no value here, there is no value here, and there is no value here. Okay. So what you can do in this particular case, you can just put NaN, okay, replace that particular cell where no values are there by NaN, okay, not a number, or you can write zero there, or you can write zero there. So both the things work well in practical aspects. Okay. If you are writing zero, then also it will be correct. If you are writing NaN, it will be correct. Then you try to reduce these particular columns to nothing but your arrays. Okay. So x1 you can declare x1 as an array np dot array. Okay. And in the parameter you can mention whatever is the name of the notebook. Suppose it is some pandas dataset. First of all, you have to reduce that CSV file to a pandas dataset, and then pd dot data frame, and then in the bracket the name of the row, the name of the column. So directly the entire column will be reduced to a array. Or you can directly call, if you are reducing it to a pandas data frame, you can directly call that column also. There is no problem. Both the things function well. But do remember that there is no easy way out if you are going with loops. Suppose you are accessing all the rows and columns using loops. Some people will do like that also. It will increase your computational complexity. Okay. If you can calculate the big O notation for that particular case, it would be much higher. Okay. So generally, we try to reduce the computational load. Okay, so write the code in that structure only. That will help you a lot. Then converting the pairwise distances to full matrix. Okay. Suppose this is again from scipy.spatial.distance. We are importing p-distance, then square form. Okay. So distance equal to p-distance, then as a parameter you can pass on x, which is an array. Okay. Then metric is Euclidean. Then you write down matrix is equal to square form distances. Means it will try to plot the distances in the form and manner of a matrix. Okay. So all the diagonal elements will be zero, and then with the pairwise distances would be there. Okay, this will be linked to this one, and this will be linked to this one, and this two will be linked option. Okay. Means P1, P2, then P2, P3, then P3, P2, then P2, P1. Okay. P2, P1 will be here, then P3, P1, and P1, P3 will be here, and then P2, P3 will be here, then P3, P2 will be there. So pairwise distances, it has given me as a distance matrix. That is good. Now you try to see from scipy.special import distance matrix, numpy is np, np.array. Then using distance matrix, okay, that particular function I have genuinely called the array two times. Okay. This will give me the same matrix directly. Distance underscore matrix is a function and scipy.special is a module. Okay. Answer will be still beyond. How this particular thing is used in clustering, this is important for you to understand. Hierarchical clustering. Okay. It will try to build the clusters by repeatedly joining the nearby points of the clusters. Depends heavily on the distance calculations. Okay. Example of the workflow is computing the pairwise distances, merge the closest clusters, repeat until all the points are merged. So SciPy provides this via from scipy.cluster.hierarchy, import linkage, then dendrogram. Okay. Both the functions you can import. Okay. But the distance computation will still come from your scipy.spatial.distance. In case of your k-means clustering, it uses the Euclidean distance to assign the nearest endpoint. Okay. Formula is assigning point to the cluster with minimum distance. It will try to calculate the distance of the centroid from a particular source or an origin, and the minimum value it will try to provide. Assign the point to the cluster with minimum distance. That is what it. DB scan, it what it does, it groups the points based on the neighborhood distance, NHD distance and the distance. Neighborhood radius it will try to provide as well as the distance. Distance is central to this particular algorithm. Okay, already these all three are covered in wall theory. Okay, watch those lectures if you haven't watched them. They are covered in much great detail. Very good. Then what is the difference between SciPy and scikit-learn? Okay. SciPy is used for mathematical computation, distance calculation, hierarchical clustering tools. That is scipy.spatial.distance import PDIST and CDIST. Scikit-learn is used for machine learning algorithms like k-means, okay, clustering algorithms like k-means, then DB-scan, then agglomerative merited clustering. Okay. So directly from scipy.cluster, you can import k-means and you can apply to your particular data set. Then this is the and for all these questions, SciPy helps you to compute the distances. Scikit-learn helps you to perform the clustering algorithms. Okay. To write down some of the sample codes, okay, before the examination so that you will be handy how to write down, okay, how to write down, how to calculate, okay. If a particular data set or an array is given to you, how to calculate the values, all the distance values as well as how to perform the cluster. Important to understand. Let us move forward. Formula for dissimilarity computation between two objects for categorical variables is what? Here P is a categorical variable and M denotes the number of matches. Which one is the formula? For dissimilarity computation. Dissimilarity between two particular objects you have to compute. P is a categorical variable here and M will denote the number of matches. Try to answer. Okay, okay, good. Yes, A and P is the total number of categorical variables. When M is the number of matches, the similarity, how different two objects are. So we'll take the values P minus M divided by total variable P. Okay, good. Okay, good. Okay, on our same way, that is good. Now we try to see here. Okay, correct option would be A only. Correct option would be A only. Okay, P minus N over P. Okay. That would be correct. What dissimilarity will mean for your categorical variables? When your data are categorical, then the values are labels such as red, blue, green, or your in case of your blood group, any of the blood groups, AB, O positive or negative, whatever it may be. Then marital status, single, married, or brand preference like Apple, Samsung, Xiaomi, or any of the brands. So, what is the meaning here? The data is categorical. It is divided into categories, different of the categories. Okay, that is the thing here. So, unlike your numerical variables, you cannot subtract the categories. For example, red minus blue will have no physical meaning. Married minus single means nothing mathematically because these are two different categories: married or single, or Apple or Samsung or Xiaomi. You cannot say Samsung minus Xiaomi. Okay. It will have no particular meaning. Okay. So instead of using Euclidean distance directly, you need to compare whether the category values match or not. Or for example, if two objects have same category value for a variable, it will match. If they are having different values, it is a mismatch. Okay. Then the dissimilarity will be based on how many number of mismatches will be there. The question is saying P is the number of categorical variables, M is the number of matches between the objects I and J. So now you try to see the proportion of mismatches would be nothing but total variables, that is P minus matching variable. So that will give you the amount of the variables or the quantity of the variables which are not matching. It would be P minus M. That will come in the numerator, and the total variables, that is P, will come in the denominator. Okay, that will give you the exact dissimilarity measure for your categorical variables. That is what you do. Formula was di is equal to P minus M divided by P, where dissimilarity is number of mismatches divided by total number of variables. Okay. If all the categories are matching, then P minus M, or M when it is P, then P minus P will be equal to 0. Okay. So the similarity would be 0. Then the two objects are identical on all the categories. If none of the categories match, supposedly if you are taking M as 0, then Dij will be equal to P minus 0. Yeah. That is divided by P. Then P over P is equal to 1. That is the thing. means the similarity is one, then the two objects are completely different. Some match and some don't match, then the values will be lying between 0 and 1. Okay. Of Dij, the values of Dij in that all particular cases will lie between 0 and 1. That is it. Interpretation of the values, di is equal to p minus m divided by p. 0 is the exact same match. 1 is completely different. Between 0 and 1 is partially similar. It is useful in clustering because algorithms need a way to say how different are the objects I and object j. How different are object I and object j. That is the meaning you try to deduce. Now you try to see, suppose a variable is there, gender, blood group, hostel, course, and student one is saying like this, male, then A, yes, BTech, okay. Then student two is there, or some different table is there. Then by comparison, variable by variable, male versus male is matching, A versus B is mismatch, yes versus yes is match. Then BTech versus BSc is a mismatch. Total number of variables was 4. Number of matches is how much? 2. Okay. Number of matches is 2. So number of mismatches would be 4 minus 2. That is 2. So in numerator you try to keep that 2. Then in denominator, total number of variables. Total number of variables, how much it is? It is 4. Okay. So 2 divided by 4, that is 50%. 0.5. Means what is the meaning here? Two particular students are 50% dissimilar. That is the meaning. Student is the particular categorical variable name. Okay. That is the thing here. Okay. Now you try to see more complete example. For example, in case of your variables, okay, you are taking customer A, customer B, then customer, whether it is a match, yes or no, is a question you are trying to say, okay, and analyze the data. When see here, in all of the cases, I think number of variables, okay, is 1, 2, 3, 4, 5, 5. What are the number of matches? See, this particular column, yes, it's a match. It is not a match. Yes, this one is a match, UPI and UPI. Then gold and silver is not a match. Then Android, yes, it is a match. So how many number of ticks is there? 3. So matches are 3, then number of mismatches is 2, then 2 divided by 5, then 40%. These customers are 40%. This is the meaning. Okay. Relationship between similarity and dissimilarity also you can find out. Similarity is m over 2 number of matches divided by total number of variables. Dissimilarity is p minus m divided by p, that is number of mismatch divided by number of variables. So p minus m divided by p, you can write it down as 1 minus m by p. M by p is nothing but your similarity. So if you want to calculate dissimilarity and you have been given similarity, so it would be just like probability. Probability of not happening an event would be equal to 1 minus probability of happening of an event. So dissimilarity will be equal to 1 minus similarity in the two variables I and j. Similarity is the proportion of matches. Dissimilarity is the proportion of mismatches. Proportion of matches, proportion of mismatches. Okay. Then di is equal to p minus m divided by p. This is exactly correct. Okay. Then dissimilarity B was mismatches over matches. No, this is not correct. I don't think so. Not the standard dissimilarity formula. Okay. Dissimilarity is this one, P minus M divided by P. B would be incorrect. C would also be incorrect. Okay. Because M is less than P. Okay, less than or equal to P. So it cannot be. The expression is usually negative or zero. Okay. So it cannot be negative. C won't be correct. D also won't be correct. Okay. M minus 3 divided by M. All the options, rest of the options won't be correct. Correct option would be A only. Then one important concept is simple matching coefficient. Yes, simple matching coefficient is nothing but M over P. Similarity is SMC or simple matching coefficient if you want to calculate. That is nothing but the number of matches divided by total number of variables. The similarity is nothing but the 1 minus simple matching coefficient. That is 1 minus m over p. Already we have seen in the previous slide. So Euclidean distance is not ideal here. You already know that the comparison between the two categories numerically, if it has to be made, then it cannot be done in the form of the subtraction of the distance, subtraction of the variable names. It cannot be done in that particular form and manner. So you usually use the mismatching, okay, Hamming distance or simple matching distance. For categorical variables, we use these three concepts. One of the concept that is matching or mismatching. We will see. Okay. Connection to the Hamming distance. Hamming distance it counts the number of positions where two categorical variables they differ. Okay. If two objects differ out of in two of the five variables, then the Hamming distance will be equal to 2. Normalized dissimilarity will be equal to 2 over 5. That is 0.4. So formula will be normalized Hamming dissimilarity. This we'll see in another example if it is at all required. But remember till here, till all these 10 points, try to remember what is similarity, what is dissimilarity, okay, and what is simple matching coefficient, and how from a particular categorical table, if it is provided to you, you can calculate the dissimilarity, you can calculate the similarity, as well as you can calculate the simple matching coefficient. Sure. This should be clear to you. Now we try to see answer this particular question. Select the correct option for a dataset with 7 objects and an interval scaled variable f. We have the following measurements. F is equal to 1, 2, 3, 4, 5, 8, and 50, containing one outlying value. Okay. Then you have the options standard deviation and mean absolute deviation are having the same effect of the outlier. Mean absolute distance is more affected by the outlier. Standard deviation is less affected by the outlier, or standard deviation is more affected by the outlier. Here, there will be a full stop. What if we stop here? Full stop there. Try to give your opinions. Yes. What happened? No opinions? Try to give your opinions. Me? Okay, good. Me? Okay. Okay. Now you try to see correct option would be D. Okay. It won't be B. It would be D. Standard deviation is more affected by the outlier. Okay. Deviation is less affected by the outlier. No, it is not correct. Mean absolute deviation is more affected by the outlier. This is also not correct. Standard deviation and mean absolute deviation are having the same effect of the outlier. This is also not correct. They cannot have the same effect. So question is asking you are given an interval scaled variable. Okay. That is f is given as 1, 2, 3, 4, 5, 8, and 50. Seven objects are there. Okay. Seven objects or seven observations are there. And the value 50 is clearly an outlier. Yeah. Value 50 is clearly an outlier. I declare it as an outlier. Okay, the question is asking between standard deviation and mean absolute deviation, which one is more sensitive to that outlier, which is what? 50. Okay, correct option will be D. Understanding the data 1, 2, 3, 4, 5, 8, and 50. Most values lie between 1 and 8. One value is 50. 50 is an extreme outlier. The Now you try to see this is the exactly kind of the situation where we compare the mean absolute deviation or standard deviation. Outlier is mattering in the clustering because it can dominate the scale, it can distort the distance, it can mislead your clustering algorithms like k-means, hierarchical, or DVS scaling. First of all, compute the mean, it is coming to 10.43. Okay. Sum of all values divided by number of observations. Value I am getting the value as 10.43. Mean itself is always already being pulled upward by the outlier 50. Okay, otherwise the mean would be somewhat between ranging between 4 and 5. Without 50, the average of the first six values would be much smaller. Okay. Then mean absolute deviation, if you try to compute it numerically, SF is given by 1 upon n summation whole I raised to power summation from I equal to 1 to n fi minus f bar, where f bar is the mean value. Okay. And all the mod values we have to compute. Okay. Mean absolute deviation measures the average of the absolute distances from the mean. So these are the absolute values, not the square values. So it will this that will make it less sensitive to extreme value rather than your standard deviation. If you will calculate it, f bar will be equal to 10.43. Now you try to compute fi minus f bar. Fi value one you have been given 1, 2, 3, 4, 5, 8, and 15. Then fi minus f bar, just the difference between all the values. Okay, so huge difference is there in 50. It would be 39.57. And all rest of the value that is minimal. Dividing by 7, SF is given the value, giving the value 11.31. Mean absolute distance. If you try to compute the standard deviation, you need not to do it in the examination. Here, just I have uh, just given it to you so that if I calculate all the values here, okay, so in the examination, you are able to remember all the concepts in a better form and manner. That is why I have computed all the distance. If it comes in the examination, just remember the fact, okay, and mark the answer if it is an objective type of question. But if it is a subjective type of question, then you need to give the explanation. Likewise, I have given here. You compute the standard deviation, it would be the measurement of the average of square deviations from the mean. Okay. So fi minus f bar we already have computed. You just calculate the squares, okay, and then sum it up and divide by the values. Okay, divide by total number of values. Okay. Total number of values. If you are dividing, you will get it as just one second, guys. हाँ दादा बोलो. नहीं 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 दादा मेरा क्लास है 6 से 8 तक रहता है. हाँ हाँ. क्या लैब का की अच्छा. वर्षों को की उनको दे दीजिए ना, दादा को। वो गोरदा को दे दीजिए। ठीक है। ओके। ओ, ओके। या, if you try to compute the standard deviation from the mean, okay, from the mean it would be uh, exactly equivalent to 10.43. Okay. If you try to compute fi minus f bar whole square, okay, fi minus f bar you are computing like this, whole square you are computing like this. Okay. So you try to sum all these values and divide by the number of observations, 1 upon n. Okay, 1 upon n summation fi minus f bar whole square. Okay, summation from I equal to 1 to n fi minus f bar whole square and under root of that particular value that you have to compute. Okay. So if you will try to compute the last particular row, okay, that would be too much huge. 1565.78. So that would be huge. That is exactly why the standard deviation is strongly affected by the outliers. That is what was given in statement number D. Okay, so D will be correct. Calculate the standard deviation. Yeah, you have to sum all the values, divide by 7. It would be 16.29. Comparing the values, two different values, mean absolute deviation, that would be 11.31. Standard deviation would be equal to 16.29. Then the standard deviation is more inflated by the outlier. Standard deviation would be more inflated by the outlier. It is more affected by the outlier. That is the thing here. So mean absolute distance, it will use x minus x bar. Standard deviation uses xi minus x bar whole square. Okay. So large deviations will get magnified. That is the thing here. So key conceptual reason is then in most of the competitive exams or your interviews, why the standard deviation is more affected by outliers if it is given asked to you, because it squares the deviations. All the values are getting squared and added. Okay. So that is the reason. All the values are getting squared, added, and then they are getting divided by the number of values. Okay. So absolute deviation square is there. Okay. So one outlier will contribute 40 to mean absolute distance. For example, an observation is 40 units away from the mean. For example, if an observation is 40 units away from mean, then it will contribute 40, the numerical value 40 to mean absolute distance. Okay. But it will contribute 40 whole square. 40 whole square, that is 1600 to your variance calculation. Okay. Or standard deviation, which is nothing but your under root of variance, standard deviation calculation. So to your standard deviation calculation or your variance calculation, it is contributing 1600. That is massive difference. That is why one value can dominate the entire standard deviation. That is the thing. Now you try to answer this particular question. Select the correct statement about standardization in the following options. Standardizing the data always gives inefficient result while making clusters. Standardizing the data always is beneficial during clustering analysis. The variables having an absolute value may not efficient after standardization using clustering analysis. Outliers cannot be detected by the standardized data. These are the four options. C. Okay, good. B. Okay, good. B. That's very good. B. Good.
Hello.
Yes.
Good evening, sir.
Hi, good evening.
Good. Sir, your
Yes,
voice is not audible.
I'm not speaking anything. I was just giving you some time so that you can think for the question. Okay, I'll speak up now. Is it audible now? Hello. Please confirm anybody else. My voice is audible, not audible, or it is not audible.
Audible, sir.
Okay, audible. Then we shall proceed. Okay. Question number four was this one. Select the correct statement about standardization in the following options. And the options were given. Out of these particular options, only statement C is correct. Where the variables having an absolute value may not be efficient after standardization using the clustering analysis. Okay. Standardization means in clustering, we often have variables on very different scales. For example, age is 18 to 70. Okay. And income is 10,000 to 1 lakh or 1 crore. Height is 150 to 190. Exam score is 0 to 100. If you try to directly compute the Euclidean distance or distances directly, variable with the largest numeric scale will be dominating. That is why we tend to use a matrix which is standardization. A method which is known as standardization. It fixes this by putting all the variables on a common scale. Okay, common global scale. Most common form is Z score standardization, which is nothing but x minus x bar divided by s, where x is the original value, x bar is the mean, s is the standard deviation. Mean will become approximately equal to 0, standard deviation will become approximately 1. All the variables are brought to a comparable scale. Okay, that is the thing here. Standardization is often used in clustering, such as because clustering methods use k-means, hierarchical clustering, DB-scan, agglomerative clustering. They often rely on distance measures, especially the Euclidean distance. One variable is measured in large units and another in small units, then the large scale variables always try to dominate. That is why you tend to use the process of standardization. Okay. X minus x bar divided by standard deviation. Weight, if it is in kg, values around 50 to 100. Income, if it is in rupees, values around 20,000 to 2 lakh. Okay. When a small difference in income numerically overshadow shadow a big difference in weight. This is an example. But standardization is not always beneficial, okay? Because that is the exact trap which was there in the question. Standardization is always good. This is not correct. Okay. Sometimes the original scale will itself contain some meaningful information that is hidden. If you genuinely try to imbibe standardization into each and every data set, you have to look the data set, compute some matrices, see the variation, then embed the standardization in that particular question or not. That shall be your decision. Okay. That is the thing. That is indeed the written in option number C. The variables having an absolute value may not be efficient after standardization during clustering analysis. Okay, if the absolute magnitude of the variable is inherently meaningful, then the standardization may not be appropriate. May not be appropriate. Okay, this is true. Suppose if you are having a clustering industrial machines based on engine temperature, vibration, fuel consumption, and if temperature above certain absolute threshold is physically very, very important, then standardizing the temperature may hide the fact that machine is genuinely operating at an absolute dangerous level. Okay. So in medical or in your engineering data, absolute units matter. Okay. So standardization can remove the useful domain meaning. That is why C is the correct option. C would be the correct option, which was the variables having an absolute value may not be efficient after standardization during clustering analysis. Other options, if you see, standardizing the data always statement. These are seldom correct. Always gives inefficient result while making clusters. No, it is not true. Standardizing the data always is beneficial during the clustering analysis. That is also not correct. Reason already I've told you. Then outliers cannot be detected by the standardized data. No, it can be detected. Because the variation with the mean. Okay. Suppose in the previous example only 1, 2, 3, then 4, then 5, then 6 and 7, 8. Okay. And one value is 50. The deviation, if you will try to standardize it with the x minus x bar divided by standard deviation s, okay, try to linearize the scale or standardize the data, still the variation of this particular data, which is the outlier, will be very, very high as compared to rest all of the values. So it in itself is correct. Outliers cannot be detected by this standardized data. This statement won't be correct. Is okay. Let us move forward. Okay. This is the explanation. Okay. Key principles you should remember. Standardization is useful when variables are measured in different units. No variable should dominate because only of scale. Okay. Relative variation matters more than the absolute magnitude. Actual scale carries meaning. A variable's absolute level is important. Domain specific thresholds matter. And the outliers are present and distort the G scores. This is the entire concept. Option A was standardizing the data always gives inefficient result. No, it is not correct. Standardization is not always bad. It is also in the same format manner, not always bad. Correct. Okay. Always it is not beneficial. C option is this one. The variables having an absolute value may not be efficient after standardization during clustering analysis. That is correct. Option D is outliers cannot be detected by standardized data. No, it is not correct. In fact, these standardized values are often used to detect the outliers. Okay. If you standardize it with x minus x bar divided by s, then observations with mod of z greater than a particular value will try to help you identify outliers. Option D is incorrect. Let us move forward to the next question, which is which of the following can act as possible termination conditions in k-means? One is for a fixed number of iterations, assignment of observations to clusters does not change between iterations except for the cases with bad local minimum. Okay. Centroids do not change between successive iterations, terminate when RSS falls below a particular threshold. A is 1, 2, 3, 1, 3, and 4. B is 1, 2, 3, 4. C is 2 and 3. D is none of these. Try to give your opinions. C. Okay. C here. Okay. If you see this particular question, then B would be correct. Okay, only B would be correct. That is 1, 2, 3, and 4. All the options are correct. Possible termination conditions in K means. Okay. I'll explain you each and every statement. How the key means K means clustering algorithm works. K means will iteratively perform two particular steps. That is assignment step, which is to assign each data point to the nearest centroid. Then update step, recompute the centroids as the mean of the assigned points. Okay. These steps are repeated until a convergence condition is met. So termination condition means when I should be stopping the iterations. Okay. So K means is an iterative optimization algorithm. You need to stop the criteria to stop when solution will stabilize, further improvement is negligible, or you hit a computational limit. Okay. Evaluating each option for a fixed number of iterations. Okay, for a fixed number of iterations, this is a very common practical stopping rule in case of your K means. Okay, because it prevents infinite loops. Okay, you will not be jumping into an infinite loop condition. It will try to control your computation time. It is useful when K means is in production systems. Then, for example, like this K means directly call number of clusters as 3 and maximum iterations as 300. Directly I have provided this stopping condition, very common. Then assignments do not change means assignment of observations to the clusters do not change between the iterations. Okay. This means every point remains in the same cluster as in was the case in the previous iteration. So no reassignment occurs. This is also a particular case. Clustering has to be stabilized. Even if centroids might adjust numerically, the cluster structure is fixed only. Okay. So the question will mention except for cases with a bad local minimum. Okay, that is correct because K means can converge to a local minimum, not necessarily to a global optimum. It does not validate this as a stopping condition, valid termination condition. Then centroids do not change. Centroids do not change between successive iterations. This is another classic convergence criterion. So the cluster centers are stable or no further update is required. Even if centroids do not change, the assignments also won't change, especially for strong convergence. Okay, it is a valid termination condition. RSS or the residual sum of squares is below some particular threshold. This is also a valid termination condition. Terminate when RSS falls below a particular threshold. What does it mean? It means that in K means the objective function, okay, objective function which is given like this, RSS equal to particular sum of all the values xi minus mu k, where mu k is the mean or the value towards you want to target. Okay. So if it is less than below a certain threshold, then also it is a termination condition. Okay. It is also known as within cluster sum of squares or inertia condition. It works because K means tries to minimize the RSS. Okay, it becomes sufficiently small, then you can stop. Often implemented when RSS is less than a particular value or a particular tolerance. It's a valid termination condition. Okay. Now we try to see here. Okay, all the correct options would be there. Fixed iterations means stop after a predefined limit. It is correct. No change in assignments. It is also cluster membership stable condition. No change in the centroids means clusters are stable. That is why you are terminating the process of clustering. Then RSS threshold. It's also objective function it gets converted. All the four conditions are correct. Okay. Option B would be correct. 1, 2, 3, and 4 includes all the valid termination conditions. Okay, matches theoretical and practical implementations. B is correct. Okay. Now we try to answer this particular question. That is question number 6. In the figure below, if you are drawing a horizontal line on the y-axis, okay, like this, for y equal to 2. Okay, y is 2. What will be the number of clusters formed? This we try to answer regarding this particular figure. Figure is this one. Okay. And line is this yellow one. What will be the number of clusters? Two. Okay, good. B. Okay. Good. Mhm. Good. Good. Now you try to see here. Okay. In case of this particular question, if you will try to see, if I cursor, yeah. Correct option will be B only. Okay, two. Why so? Because there is a particular rule for finding the number of clusters from this particular dendrogram. From this particular dendrogram, how you will find the number of clusters in case of your hierarchical clustering? If you draw a horizontal cut line, okay, at some particular height, suppose at y equal to 2, then the number of clusters will be the number of branches where there is intersection, okay, by the horizontal line. That's the standard method. So objects are D, F, E, C, A, and B from left hand side. D and F will first merge around 0.5. Okay, if you see here. Okay, then you try to see. Just 1 second. Yeah, let's see. If I can show you this and this simultaneously. Yeah. You can see from here in this particular figure. Okay. See here. D and F will first merge around this particular value, that is 0.5. So from here onwards. Now E will join them. This will join them at 1. C will be around 1.5, 1.4. Okay. So by the time when y is equal to 2, okay, all these particular values, okay, D, F, E, and C have formed a cluster, this particular cluster. Okay. This one. Okay. This is forming one particular cluster. Okay. Now in right hand side, A and B, they will merge nearly about around a particular value, that is 0.7. Okay. Distance between D and B, the center of A and B, not D and B, A and B. That is varying a lot. Okay. One is nearly around 0.6, 0.7. Another one is at 2.5. Okay. So this will form one another cluster. This one. Center of these two values. So these two will be forming one another clusters. A and B will be one cluster. D, F, E, and C will be one cluster. So the left cluster and the right cluster will merge nearly about 2.5. So from standard formation also you can calculate. Otherwise you can verify this. That why this particular thing happened. That the number of clusters went to 2. Okay. That is the thing. So at y equal to 2, clusters are D, F, E, and C, and A and B. So number of clusters will be 2. Two cuts, two clusters. Final answer is two. Next, moving forward, which of the following clustering requires merging approach? Whether it is partitional, naive Bayes, hierarchical, or none of them. C. Okay. C and C. Good. That is indeed correct. Okay. Hierarchical will be the correct option. Okay. See here, the question is asking which clustering method uses a merging approach. Okay. So when you are referring to agglomerative clustering, okay, it will be the type of hierarchical clustering. Okay. So hierarchical clustering, what does it mean? It means merging approach. Okay. Merging approach. Merging approach in clustering will mean what? Starting with a very small number of clusters, then repeatedly merging to the closest clusters until a stopping rule is achieved. So that is exactly how your agglomerative hierarchical clustering will work. Okay. Why hierarchical clustering is correct option? Because you try to see here, hierarchical clustering has two major types. Agglomerative hierarchical clustering, that is the bottom-up approach, okay, starting with observation, then reducing it to a separate cluster, then finding the two closest clusters, then merging them. Then repeatedly targeting this particular process until one cluster remains. So it's a iterative merging approach. Then divisive hierarchical clustering, this is a top-down approach. Okay, it starts with all of the observations in one cluster. Then repeatedly it starts to split the clusters. Then it's a splitting approach, not a merging approach. So in examination, if the question comes, clustering requires merging approach, it usually means agglomerative hierarchical clustering. Okay. So why partitional is wrong? Partitional clustering divides the cluster data set directly into k number of clusters. Okay. So for example, k means k medioids. These methods do not work by repeatedly merging the clusters. Instantly, they will initialize the clusters for the centroids or assign points or update the clusters. They are not based on the merging process. So name will be incorrect. Naive Bayes is wrong. Okay, naive Bayes is not a clustering algorithm. It's a classification algorithm used in supervised learning. Used for spam detection, text classification, sentiment analysis, medical diagnosis. So clustering is unsupervised. Naive Bayes doesn't belong here. So option B is wrong. Then none of the above is wrong because hierarchical clustering is clearly a valid answer. The key concept was hierarchical clustering builds a tree. So, yes, hierarchical clustering forms a dendrogram, which is a tree-like structure in the agglomerative version. The tree is built by merging nearby points, then merging the clusters, then merging larger clusters. That is why it is hierarchical. So, example of merging in hierarchical clustering. For example, if you are having points like A, B, C, and D, then each point would be having its own cluster, which is A, B, and C itself. Then suppose A and B are close, they will be forming a cluster. C and D are closest, then they will be forming a cluster. Merging the two clusters will be the entire merging process in which the entire data set will be coming. So this is an example of hierarchical clustering. That is nothing. So what is the difference between partitional and hierarchical clustering? In case of your partitional clustering, example is of your k-means. In case of your hierarchical clustering, example is agglomerative clustering. The structure is alike only flat clusters in case of your partitional, tree-like clusters in case of your hierarchical. Approach in case of your partitional clustering is partition into k number of groups, while in case of your hierarchical clustering, it is merging or splitting into the clusters. Whether it follows a dendrogram, no. In case of a hierarchical clustering, it follows a dendrogram. Whether it is merging based, no. Partitional is not merging based. Hierarchical clustering, it is indeed merging based. So if the question is saying requires merging approach, answer is correctly hierarchical. In case of your Python connection, it is from scipy.cluster.hierarchy, import linkage or dendrogram. Then from scipy.cluster.hierarchy, import linkage, z equal to linkage. And as a data set, you have to forward, you have to pass as a parameter x. In the method, you have to provide as word or any hierarchical clustering algorithm. This repeatedly will merge the cluster based on the distance. So again, it is a merging based clustering approach. Next is this particular question. State true or false. Hierarchical clustering should be primarily be used for exploration, whether it is true or false. Try to give your opinions. Yes, indeed, if you will see this particular statement, this will be true only. Okay. So hierarchical clustering should be primarily used for exploration. This is correct. Hierarchical clustering should be primarily used for exploration. This statement is correct. Indeed, if you will see, okay, this will be correct. Okay. Why this is true? Because hierarchical clustering is mainly considered for the EDA. That is your exploratory data analysis. Okay. It's a technique because it helps us to discover the natural groupings in the data. It helps us to understand the relationships among the observations, visualize the cluster structure, decide how many clusters might exist in the data set. So statement is true. Okay. Used for exploration, what does it mean? In data analysis, exploration, what does it mean? You are trying to understand the structure of the data rather than just forcing a final answer. It is immediate. Okay. What exactly, which type of clustering you will try to use? Prior to that, you go for exploratory data analysis, EDA. Okay. So hierarchical clustering is good for this because it does not require you to pre-specify the number of clusters at the start like the fields. Instead, it shows us how clusters are formed step by step. It is excellent for exploring the hidden number of patterns. Okay. Biggest reason is dendrogram. Okay. Dendrogram is a tree-like diagram which shows which observations merge first, how clusters combine, and at what distance they can combine. Okay. This gives a very rich usual understanding of the data. That is why the hierarchical clustering is often used in visual exploratory tool analysis. So, why is it not a primary final stage large scale production method? Because hierarchical clustering is powerful, subject to some limitations. It is sensitive to distance measure, scaling, and linkage mode. Once a merge is made, it cannot be undone. It is less scalable as compared to k-means. So although it can be used for final clustering in some of the cases, it is primarily valuable for exploration. That is why the statement is true. Example, in case of your variables like annual income, age, spending score, city, and production preference, you may use the exploratory data analysis. Then you try to form the clusters. Okay. Comparison with k means, okay, it is you must specify whether k what if you must specify k in advance. Okay, what is the number of clusters that will be formed? So in that particular cases, for efficient clustering, for large data sets, for final partitioning, you can go for your EDA, exploratory data analysis. For your hierarchical clustering, you need not to choose k at the start. It is good for understanding the structure, dendrogram based interpretation, or EDAs, exploratory analysis. So primarily is an important word here. Hierarchical clustering is should be primarily used for exploration. Okay. Doesn't mean hierarchical clustering can only be used for exploration. It can be used for various other things also. Okay. Its main strength is exploratory understanding. Real intuition is like this. Think of hierarchical clustering as a family tree for data points. Helps to answer questions like which observations are most alike, yeah, which small groups combine first, are their nested clusters, is there a natural split in the data? Okay, this is not just clustering, it's data exploration. When hierarchical clustering is especially useful when the data set is small to medium sized. You want a visual understanding. You are unsure about the number of clusters. You want to spread the nested grouping structure. This is exactly the kind of situation where exploratory tools are used. Why this statement is not false? Because if someone marked it false, okay, it might incorrectly think that clustering is always just for finaling grouping. Okay, it will miss the point. Okay, hierarchical clustering is often used best for exploratory methods. It helps you to discover the structure before making the decision. Statement is true, definitely true. Then comes question number 9, which is state true or false for finding dissimilarity between two clusters in hierarchical clustering. Average length is the only metric which is used. Whether this is true or false. See, this particular statement, okay, for finding the dissimilarity between two clusters and hierarchical clustering, average length is the only metric used. Okay, this statement would be false. Okay. Why is it so? Because for finding the dissimilarity between two clusters and hierarchical clustering, average length is the only matrix. Only the average length is not the only matrix. Okay, statement is false because average linkage is only one of the several linkage methods. Okay, there are multiple linkage criteria available. For example, single linkage, complete linkage, average linkage, centroid linkage, Watts method, or your median linkage. Okay, in some of the formulations, average link is the not the only linkage which is available. What is linkage in hierarchical clustering? In case of your hierarchical clustering, after you are computing the distance between individual points, you still need a way to answer this particular question. If I already have two clusters, how do I measure the distance between those two particular clusters? Distance between cluster A and cluster B. Different linkage rules produce different cluster shapes and different dendrograms. Okay. So average length, what the statement is mentioning, average length is computes the distance between two clusters as the average distance between all pairs of points across the two clusters. Cluster A is having point A1, A2, A3, plus and so on up to An. Cluster B is having points B1, B2, B3, plus and so on up to Bn. Then the linkage, average length between two particular clusters D, A, and B would be 1 upon nothing but distances. Okay, average distances A, average distance B. Then this particular distances, summation of this distances. Okay, for all the points present in both the clusters. That is the case of average linkage method. But this is not the only one. All of the options are also valid on. Okay. Other linkage methods are single linkage. If you want to go for single linkage, this defines the distance between two clusters as the minimum distance between any point in cluster A and cluster B. This is also a valid. Okay, suppose this is cluster A, suppose this is cluster B, and minimum distance between these two particular points, cluster A and cluster B, also is a valid type of linkage. Complete linkage means maximum of this particular distance between two clusters A and B. This is also an example of a linkage. Then average linkage already explained. Centroid linkage, you take the centroid of these two particular clusters and say that the linkage between those two particular clusters would be centroids. Okay, distance between the centroids of two clusters. In Ward's method, this merges the clusters based on the minimum increase within the cluster variables. One of the most popular linkage methods in practice. Okay, Ward's method is not directly. Uh, Ward's method is just 1 second. What happened? Yeah, yeah. Ward's method is not directly used in case of your average linkage. Okay. Instead, it chooses to minimize the distance within cluster sum of squares. That is, it is trying to minimize. Alone, this proves the statement as false. Average length is not the only metric, it is one of the metric that is there. Hierarchical clustering is flexible. You can choose different linkage rules, depends on the cluster shape, noise, data geometry, application needs. All of these are available. It is not the only option. Okay. So suppose you are given two clusters. Cluster A is having these particular values, cluster B is having these particular values. And pairwise distance, if you will try to calculate, one distance between 1 and 8, 1 and 10, 2 and 8, 2 and 10. Okay. You try to calculate. Then with single linkage, you will get the value as 6. Complete linkage, you will get the value as 9. Average linkage, you will get the value as 7.5. So observation, each of the linkage will give you a different clustering distance. Okay. So average linkage is not the only method, that is the conclusion. Statement is false. Already I have told you. Okay. matters in practice. Single linkage may create chain-like clusters. Complete linkage will give tighter clusters. Average linkage will give you a balanced behavior. Watt's method is also often well used for spherical clusters. Not true. It would be true if average linkage were the only value. In case of Python also, you can use scipy dot cluster dot hierarchy. Okay. That is the library. You have to import the linkage and pass on the array uh, as x. Okay, and method you can provide as single, complete, average, whatever you want to provide, you can provide. Next, the last question for the present session. If two variables v1 and v2 are used for clustering, which of the following are true for k means clustering with k equal to 3? If v1 and v2 has a correlation of 1, the cluster centroids will be in a straight line. If v1 and v2 has a correlation of 0, the cluster centroids will be in straight line. One only, two only, one and two, or none of the above. Okay. See here, try to see here. The statement would be correct. Okay, this statement would be correct. That is one only. If just one second, yes. Hello, good evening, sir. Yes, sir. Yes. सर कल लैब के लिए वो अर्गोनॉमिक्स वाला करा सकते हैं सर एंथ्रोपोमेट्री वाला सर उनसे मैं मॉर्निंग में बात कर लूंगा और सर जो ड्रॉवर पुल प्रोटेक्शन है नहीं सर वो तो एमएल वालों ने सर मना कर दिया है जी सर वो बोल रहे हैं कि हमारा एचओडी सर साइन नहीं कर रहे हैं तो हम कैसे डेमोन्स्ट्रेट ये सर प्रीवियस वीक में पूछा था मैंने यस सर बाकी सब ठीक है सर सर जी सर वो वाला सर जी सर जी सर यस सर जी सर ओके ओके सर सर 10 वाला हो बस जी सर ये बच्चों से यहाँ सबमिट कराऊंगा जी सर जी सर जी सर जी सर जी सर सर फैब्रिकेशन में सर इंट्रा रो वीडर का उन्होंने बना दिया है उसको फिक्स भी कर दिया है अब सर इंटर रो वीडर के लिए सर जो मोटर की शाफ्ट है सर उसमें कीवे होता है सर वो कट करा के कोलकाता जाना है सर उसके लिए। सीएनसी से सर वो होना सर इस मंथ के एंड तक पॉसिबली हो जाएगा। मंथ एंड तक सर हो जाएगा पॉसिबल। जी जी सर, जी सर, ओके सर। Yes, extremely sorry for the interruption. Yeah. If two variables v1 and v2 are used for clustering, which of the following are true for k-means clustering with k equal to 3? So you try to see the statement 1, if v1 and v2 has a correlation of 1, the cluster centroids will be in a straight line. If v1 and v2 has a correlation of 0, the cluster centroids will be in straight line. Okay. So only statement 1 will be correct. Okay, 1 only. That is the statement which is correct. Very good conceptual question because it will try to mix the correlation, geometry of the data, k-means, centroids, 2D clustering. So it is having uh, two variables, which is v1 and v2. We apply k-means with k equal to 3. With k equal to 3k. So statement 1 is if v1 and v2 have a correlation of 1, then the cluster centroids will be in straight line. If v1 and v2 have a correlation of 0, then the cluster centroids will be in a straight line. So you need to determine which are true. Okay. So first is what does correlation equal to 1 will geometrically mean? Okay. If you are having a perfect positive correlation, then correlation between v1 and v2 is equal to 1, then all the data points will lie exactly on the straight line, which will form as like this: v2 is equal to a plus b v1. Okay. Y equal to mx plus c. Okay. That is how it will be formed. That will mean that the entire data is perfectly linear. Every point lies on one straight line. There is no scatter away from that line. Okay. So the data set in 2D is effectively one dimensional. Okay. So what happens to k-means centroid in this particular case? K-means centroids are simply means of points which are assigned to each of the clusters. So if all data points lie on a particular straight line, then any subset of those particular points will also lie on the same line. Okay. So all and the mean of the points lying on the line will also be lie on that particular line. Okay. So K means if it is forming three clusters, okay, centroid 1 will lie on the line, centroid 2 will lie on the line, 3 will also lie on the same line. So three centroids will be collinear, so statement 1 will be true. Statement 1 is true if V1 and V2 is having a correlation of 1, then the cluster centroids will be in a straight line. Yes, this is statement is true. Now we try to analyze the second statement. If mathematically also it is correct. Okay. V2 is equal to A plus B1, BV1. Okay. You take the mean of the cluster, V1 bar and V2 bar. Because the average will preserve the linear relationship, V2 bar is equal to A plus B V1 bar. Okay. So the centroid will also lie on the same line. Clean mathematically it is correct. Okay. Now you analyze the correlation. Okay. Supposedly, if the correlation V1 and V2 is equal to 0, what does that mean? It means that there is no linear relationship between V1 and V2. Okay. So, correlation is 0. It does not mean that the data point lie on the straight line. In fact, it actually means the opposite. The points are scattered in 2D, so no linear trend exists. The cloud may be circular, random, or non-linear. So there is no reason for the k-means centroids to fall on the straight line. So statement 2 will be false. No particular reason exists because the correlation is equal to 0. Between two particular clusters, if the correlation is equal to 0, there is no linear relationship between the points, the clusters V1 and V2. Hence, you cannot say that the mean will lie on the straight line. So correlation equal to 0 does not imply centroids in a line. Okay? If correlation is 0, maybe it means that the line is either horizontal, like this, or it might be vertical, so like this. So correlation equal to 0 simply means there is no linear association. Cannot say. It may not enforce the straight line arrangement. Data could be any of any shape, circular, globe shape, randomly scattered, symmetric, non-linear. Statement 2 is not right. There is no guarantee. In case of statement number, it would be false. Okay. So suppose if you are imagining a points like this example 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Okay. These all lie on the same clusters. Okay. So cluster 1 you can imagine, okay, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Centroids will be like this 1.5, 1.5. Okay. Then 3.5, 3.5, then 5.5, 5.5. Clearly they will be lying on the same straight line. Okay. So statement 1 will be true. Now, if you are imagining these points, in this particular case, correlation is somewhat non-zero or equal to zero because these are randomly scattered. Some are vertical, some are horizontal. So K means might create clusters with centroids like this 1.5, 3, 3.5, 3, 5.5, 4.5. Maybe these happen to look aligned, but there is no guarantee it would be forming a straight line like this. Statement 2 is not right. So exact logical interpretation which will happen. The question will ask that what is true in general. Okay, you are looking for can it happen sometimes? Okay, we are looking for is it necessarily true? So in case of correlation equal to 1, centroid must lie on a straight line, that is true. In case of correlation equal to 0, centroid should not to lie on a straight line. Hence it is false. That is the thing there. So only statement 1 will be true. Rest of the statements won't be true. That is the thing. So in case of K means what? Why K means matters here. K means create centroids by taking the means. Okay. So centroid position depend on geometry of the data. If the entire data set lie on the line, then all clusters lie on that line. Data set is spread in 2D. When the cluster means can be placed anywhere on the plane. So there is an important statistical interpretation. If correlation is equal to 1, then means are V2 equal to A plus B1, V1. Okay. So perfect linear relationship is there. Data are effectively embedded in 1D. So K means centroids are also 1D embedded in 2D. Okay. So correlation equal to 0, it means you cannot say about the cluster alignment, centroid collinearity, geometric stiffness. 1 would be correct, 2 only won't be correct, 1 and 2 won't be correct, none of the above won't be correct. Correct option would be this one only, that is statement 1 is only correct. So importing numpy as np, V1 is np dot array. Suppose you declare it as an array, then V2 as V2 and V1 you try to keep it same. Okay. So if they are same, means K means will guarantee that the correlation will be exactly 1. Okay. In this particular case, K means will produce the centroids on the same line. But if you are generating uncorrelated random data, like in this particular case, V1 and V2, I have just done. Then the points are scattered, centroids will not be exactly collinear. Exact collinearity will be there. This is the test which you can perform. Okay. And this marks the end of the 10 questions which I wanted to discuss. Sorry, there is a 10-minute delay from my side because I wanted to discuss the questions in great detail, as detailed as possible, and I included the coding part also within the slides also. So sorry about the time. Okay. And this marks the end of the 10 questions which I wanted to discuss. Thank you all for joining the session. Okay. And do join the sessions next week, same time, same day. And I want to inform you all that there will be one another extra summary session. Okay. That will be mostly conducted, I think, on Tuesday. Okay. On Saturday, not Tuesday. Extra summary session. Okay, it would be there in which I will be summarizing all the concepts from 1 to 12 weeks. Okay, so do attend it. Okay, mostly it would be, I think, between 3 to 5 on Saturday, as far as I remember. Okay, so you can just uh, go for that. Okay. I think on April 11, I kept it on April 11, 3 to 5. Timing might be changed. Please check your emails. Okay. Do join that session also. I'll be summarizing all the content from week 1 to week 12. I will try to summarize within 2 hours. Okay. And
Uh,
this, yes,
Good evening, sir.
yeah,
Sir, I want to ask one question. I have a doubt that in the examination, they will ask that the how to perform the code of Python in the examination.
please beware with that. If that is taught in the video lectures, there is a possibility, okay, that one or two questions might appear. But most of the questions will be based on the same pattern in which we have just formulated the assignments. Okay. The assignments as well as the questions which I am discussing, the questions will be almost alike. Okay. In
Okay,
some
sir.
of the questions, coding part is included. Okay. You are only expected to master the content which is given to you in the video lectures, what sir has taught to you. Okay, as well as what we are teaching here. Okay, we are discussing some of the questions in which some of the coding part is embedded. That only you try to be thorough with. Okay.
Actually, sir, I want to clear my concept regarding each and every week content, but I
Mhm.
want to ask about the Python part.
Okay,
So,
okay.
uh,
Yes, you can ask.
that's
No problem. No problem.
Python part. Yes, in Python, actually, they will ask that do and run the particular command in the examination. For
No,
example, mean, median, and anything.
no. That won't be there. Don't worry about it. That won't be there. It would be somewhat objective or subjective. Okay. So whether you would be given a
Okay.
line, you would be asked to formulate the error, okay, or it would be a writing a simple code, okay, that you might be aware of, okay. So it won't be like that you would be given a PC and in that you have to run. I don't think so. That's a possible.
Okay. Okay. Thank you, sir. Thank you so
Okay.
much.
Okay. Questions will be almost alike as compared to the assignments. Okay, be thorough with the assignments as well as the content, video lectures which we are releasing week wise, as well as the doubt solving sessions if you are attending. Both the facilities are available. You can go through the PDF also if you are not having the time, as well as you can watch the recording also. Two particular sessions are being are being held. Okay, for you only. Okay.
Okay. Okay. Okay. Thank you, sir.
Uh, Okay, thank you very much for joining the session. We join the session next week, same time, same link, as well as join the summary session whenever the mail comes. Okay. It is subject to the approval of the NPTEL team. They will mail you. Okay. To all the students, okay, whomsoever have registered, the mail will come. Okay, do join that. And thank you so much. Okay. Have a great day ahead. And if you are having any doubts, feel free to ask. Rest, I'll also leave for just 2 minutes. Okay. Thank you once again. Okay, thank you everyone.
गुड इवनिंग सर
Yes, yes.
सर एक्चुअली ना ड्यू टू सम रीजन एक्चुअली मैंने ना वीक 1 to 10 तक की ना असाइनमेंट सबमिट नहीं करी थी
Okay.
तो सर उससे अब स्कोर पे तो नहीं कोई मतलब इफेक्ट पड़ेगा
बिल्कुल पड़ेगा. Why it won't be affecting? Assignments are having some of the weightage in the mass.
या
You have
सर
to.
आई नो दैट बट मैंने ना सर उनको ना मेल भी किया था सपोर्ट वाली मेल पर
Hmm.
कि सर मुझे ना बहुत मतलब इमरजेंसी थी मेरे घर में तो मैं सबमिट नहीं कर पाई थी 1 to 10 वीक की
So what they have given the reply?
सर उन्होंने तो यही बोला कि बेस्ट डेट वहां से काउंट होती हैं तो हम लेकिन अब ओपन तो कर नहीं सकते असाइनमेंट्स
Because the solutions already have been released. So how they can open the assignment for you? That is the thing. No?
या सर आई अंडरस्टैंड
Mhm.
बट सर मेरी भी बहुत फैमिली इश्यूज थे
Yes,
मतलब रीजन था
I understand that, but Talk to them only. They are in the situation. They can provide some of the solution to the problem. Talk to them. Okay.
Sir, is there any alternate option to gain a certificate?
I am not aware of any of the alternate option. I have also joined. See, I'll show you. I have also joined this particular course. I am not appearing for the examination. Still, I have joined. Okay. I am also receiving the same news as you are receiving. See here. So in
Oh,
that particular mail only, they have mentioned that submitting timely assignments is an essential criteria for obtaining the certificate, as well as
yeah.
the terms and conditions also they have mentioned. Okay. So they will
Yeah.
be in the particular position to answer you that whether they are exempting for you or not exempting for you. Please talk to them only. Okay.
Okay, sir.
Yeah.
Thank you.
Okay. Okay. Thank you, everyone. I'll end the session for you all, guys. Thank you so much. We'll go on the session next week, same time, same link. Yeah, have a great day.